Negative 2 is 1/4. Negative 1 is 1/2. 0 is 1. 1 is 2. And 2 is 4. And so we've plotted those. Here's that negative 2. Negative 1, 1/2. 0, 1. 1, 2. And 2, 4. And that's going to continue up in both directions. All right, that's an exponential function. What would the inverse look like? Okay, now we've gone over inverses and we've gone over inverse graphs. What would the graph of the inverse look like? Now, remember, for an inverse, what flips? Okay, remember, if xy is on your original graph, then what point is on the inverse? Yx. Those flip. So for f inverse of x, then your xy's will be flipped. So it'll be 1/4 negative 2. It'll be 1/2 negative 1. It'll be 1, 0. It'll be 2, 1, and it'll be 4, 2. So remember how you do that. Plot those points. Okay, plot those points. So I got 1/4 negative 2. I got 1/2 negative 1. I got 1, 0. I got 2, 1. And then I got 4, 2. Another fact, we stated that it is a reflection over the line y equals x. So if you got that line, it needs to be a reflection. Now, our original function had a horizontal asymptote. Well, if you think about this, where's that horizontal asymptote? It's actually going to, if it flips over that line, it's actually going to become a vertical asymptote. Okay, and so the graph, okay, is going to look like this. And it will have a vertical asymptote at 0 here, x equals 0. All right, so there is our inverse, okay, function. We've got it graphed. We can see it. Now, let's find the equation for f inverse of x. Well, we know f of x, equals 2 to the x power, right? And so remember what we do to find the inverse. We just let y replace f of x first of all. And then what do we flip? We flip the x and the y. And so now it becomes x equals 2 to the y power. Well, what do we got to solve for? Got to solve for y. All right? How do we solve for y? Yeah, we got a problem. Because y is in the exponent. We can't algebraically manipulate that to get y by itself. You can't even, like, a lot of times you want to say, oh, I'll take the y root of both sides, which would give you 2 over here, but now you got that. And that's not y by itself. Okay. So we're kind of stuck. And so this is where actually logs come into play. So y will actually equal log base 2 of x. That will be the inverse. But we haven't been able to solve, we can't solve for that algebraically, so we're gonna make up logs for this. All right, so right now we're going to define logs. We're going to evaluate them. So it's kind of our first. I know you brushed upon them last year, but this is, I think, one of those things that takes a couple times to see it, to really sink in. there is a good bit going on here. We're not going to get through all of this today, but we're just going to hopefully get through the basics today. The inverse of an exponential function is a logarithmic function. All right, so that's that first sentence right there. The inverse of an exponential function is a logarithmic function, and then vice versa. The inverse of a log function is an exponential. So we've dealt with all exponentials in section 4.1. Now we got to get into the inverses. So f of x equals 2 to the x. The inverse is log base 2 of x. That's kind of how you read that. This is the base. It is a subscript. Okay, for that. Now, just pay attention here. Now, I got to be careful because I probably should have reversed the order. Remember, if xy is a point here, then it flips to yx. Well, if I plug in 1 here, okay, it's actually that point, I get back 2. So that is the point 1, 2. So that means when I plug in 2 here, I got to get back 1. So that has to hold. And 2 squared equals 4, which means I plug in 2, I get 4. That means when I plug in 4, I get 2. And then when I plug in 3, I get back 8. And so when I plug in 8, I get back 3 for that. The answer to a log, okay, the answer to a log is always an exponent. Okay, that's going to be important as we kind of move forward. So right here, here's your exponent. There's your answer. Your exponent is 2 here. That's our answer over here. And so we get that answer there. So the answer to a log is always an exponent. Okay, for that one. Do you remember how to read these or what's going on with logs? So log base 2 of 8 equals 3. Do you know kind of how to get a little bit in? This is your base. This is your power. And this is your answer. So you basically kind of need to think backwards. So it says 2 to the third power equals 8. So when we're thinking about logs, the answer says that's what power? What power? 2 to what power equals 8? Well, 2 to the third power is 8. Okay, for that. All right, now here's your definition for a log function. Okay, x is greater than 0. Okay, a couple key things here. A is greater than 0. A cannot equal 1. A is our base. Okay, we call that our base. Whatever we're taking the log of has to be positive. It cannot equal 0, has to be greater than 0. Y equals log base A of x if and only if x equals a to the y. Okay, if and only if x equals a to the y. Now, so y equals log base a of x. A lot of you learned the little swoop method, right? So that means if you got log base a of x, that means a to the y. Hold on here. That means a to the y equals x. And which I just have it reversed. So the base to the power has to equal that x. Okay, so that's kind of how the logs and exponential functions are related. Okay. So this means log base a of x has to equal that exponent. Now, most of you probably know that John Napier was the inventor of logs. Now, what year did he invent them? So what year? Max, what do you think?
I don't know. A long time ago.
Long time ago. A long time ago. There's that could be there's a big discrepancy. A long time ago for me would be like 1960. That'd be a long time ago.
Probably longer than that.
Longer than that? All right, Marissa, give me a year.
1895.
1895. All right, you're getting closer. You're getting closer. But further back, we're going back to, he published his book in 1614. Okay, back there. So back in 1614, closer than 1960 for that. So he is one of the single greatest advances in the history of math was dealing with the logs. Okay, so pretty important. And you guys don't even know John. Okay, so he needs a little bit of credit. I want to make sure you got to see him. All right, converting from exponential to log form. You need to take any exponential, you got to be able to write it as a log. So this case right here, 4 to the third power equals 64. The answer to a log is always an exponent. So it says the log. So how we do this is the log base 4 of 64 equals 3. Okay, the log base 4 of 64 equals 3. So some people do this, 64 to the 3. Okay, swoop that. 3 to the negative second equals 1/9. You need to understand that that's true. So if I'm converting this to log form, log base 3 of 1/9 equals -2. This 1/9 always has to be positive. We cannot take the log of 0 or negative number. Always has to be positive. And then the third one here, 5 to the 0 equals 1. I think we agree with that. So that is the log base 5. Okay. Whoops, hold on. The log base 5 of 1 equals 0. So we say 5 to the 0 equals 1. All right, so that's converting to log form. Need to be able to go backwards. Converting from log to exponential form. All right, log base 3 of 9 equals 2. I think this is a little bit easier because when you get that exponential form, you know whether it's right or wrong. And if it doesn't make sense, then you kind of did something wrong. So log base 3 of 9 equals 2. So you start with the base, go around to the exponent here. So that's 3 squared equals 9. Log base 10 of 1,000 equals 3. 10 to the third equals 1,000. 10 to the third equals 1,000. And then lastly, 2 to the negative third, because that's 1 over 2 cubed, equals 1 at 8. Logarithms of 0 and negative numbers are not defined. All right, I really want you to think why. What if I put a negative in there? Log base 2 and -4. What would that look like in exponential form? Okay, what would that look like in exponential form? So down at the bottom, you cannot take the log of 0 or a negative number. If I do this and I convert to exponential form, it says 2 to the x equals -4. Well, what's wrong with that? Because what's 2 squared? 2 squared is +4, because that would be your first inclination. 2 squared is +4. Your other inclination is what's -2? What's 2 to the -2 power? It's 1/4. The answer we get back, no matter what my power, is always a positive number. So you cannot take the log of a negative number. You cannot take the log of 0. We cannot take it 2 to a power to equal 0. Okay, for that one. So that's going to be a pretty big fact as we move forward. All right, you got 2 kind of special logs. I go on the next page. And let me pull up my calculator here. Okay. Common log, base 10. And then what's called the natural log is base e. So we just went over the number e, and that comes up a lot in logarithms. Okay. Base 10. Now, if you have it written, it is understood. If there is no base there, it is understood to be base 10. If you look on your calculator, okay, right there next to the 7, it says log. That is base 10. Okay, that is base 10. So log of 100, that is going to equal 2. Base is 10 to the second power equals 100. The ln, right here, that is automatically base e. Now, this is what it means. Do not write it that way. I do not want to see log base e of x. I just want to see ln. ln of x is understood to be base e. So if you talk about ln of 12, this is saying e, so ln of 12 equals, say, x. This is saying e to what power equals 12. Okay, that's what that's saying. And so if I hit ln of 12, gives me 2.48. And then if I do second e to that power, it's going to come back 12. Okay? So understand that base 10, you don't write it. Base e, ln of x. Those are the two things. Those are the two buttons on your calculator. Now, I think a lot of you, I'm trying to think where it's at, where you could do different bases on here. Let me see where that's at. You know?
Nope.
Under math. Log base. Okay. Yes, I don't have it, but if you go under math, if you go all the way down, past there, it should say log base. Hit that. What's it look like? Okay, and so you can type in the base, and then you can type in the number. So it'll, I think it's past those two, I think past solver, but I don't have it on mine. So you can type in different bases into your calculator. You should not be able to. But those are your two cases here. All right, you're going to need to know how to do this without a calculator because that's just kind of gives me your understanding. All right, log of 10. Log of 10. All right, do you know what that is? Do you know what it's asking? I guess I just need to kind of see that first. All right, Wendy, do you know what the answer is?
Is it 10 to the base equals 10?
So do you know what the answer is? You kind of got everything right, but do you know what we would put for the answer? Log of 10 equals a number.
Oh, is it 1?
It's 1. Yep. Now, let me explain this. Do my best to explain this. When you see this, if you don't know what the answer is by looking at it, what you can kind of do is just set it up, think of it as an equation. So what do you want? Log of 10 equals something. Well, what does this mean? Convert it to exponential form. Log of 10 means this is the base 10, and it's saying 10 to what power equals this number right here. 10 to what power equals 10? Well, 10 to the first power equals 10. So the log of 10 equals 1. What's the log of 100? Think about that. It's saying 10 to what power equals 100? 10 to what power equals 100? 2. So the log of 100 equals 2. Now on your calculator, and I noticed that don't use it, but just to verify it, so if you hit log of 10, it's going to give you 1. If you hit log of 100, it's going to give you 2. 10 to that power is 2. Okay? Log base 2 of 8, without using your calculator. Log base 2 of 8. Need to understand what it's saying. It's saying 2 to what power is 8? Well, what's that answer? 2 to what power is 8? 3. It equals 3. So you need to think. So log base 2 of 8 equals some number if I don't recognize it. So I say, all right, 2 to what power equals 8? 2 to what power equals 8? So it's going to be 2 to the third power. All right, I want you to think about this one. So you can figure it out without using your calculator. Log base 4 of 2. Log base 4 of 2. All right, not as easy, right? Not as easy. So you got to think about this. So we're saying log base 4 of 2 equals some number. So that means 4 to what power equals 2. All right, so let's just kind of work our way through here. If x is 1, what's 4 to the first power? That's 4. If x is 2, it's 16. If x is 3, it's 64. We need something smaller than 4. So it actually has to be smaller than a 1 then, because if x is 1, we get the number back 4. Any ideas? Peyton?
1/2.
All right, 1/2 is the answer. Because that's the square root of 4. The square root of 4 is 2, and that is the 1/2 power. So the log base 4 of 2 is 1/2. Okay? X equals 1/2. Don't forget that the square root of a number is the same as the 1/2 power. The cube root of a number is the 1/3 power. Okay? All right, so take a look at this one and see what you come up with. Log base 9 of 1 over 81. So I'm saying, so I got log base 9 of 1 over 81 equals some exponent. 9 to what power equals 1 over 81. That's what we're saying. Well, 9 to the first is 9. 9 squared is 81. But we want 1 over 81. So Alex, you know what x is?
-2.
-2. Because 9 to the negative second power. Okay, if you're going to have a fraction, okay, then you have to have a negative exponent. You have to have a negative exponent. Okay. All right, this is that last section we're going to do. We're not going to finish all of these today. Find the domain of each function. F of x equals log base 2 of 5 minus x. All right, I don't know what this graph looks like. We'd have to look at the original one and then do a transformation, but we're not going to concerned about that. But what in our definition, something has to be true about that value. Remember from our definition, that value has to be greater than 0. Okay, so right here, this has to be greater than 0. You cannot take the log of 0 or negative number. So for this one here, we just need to do 5 minus x is greater than 0, and then solve that. Well, I'm going to add x, so I get 5 is greater than x, which means x is less than 5. So my domain is negative infinity to 5, does not include 5. It does not include 5. All right, copy down to the second one. All right, g of x equals log base 5 of the square root of x minus 4 minus log base 5 of x plus 1. Okay, you cannot take the log of a negative number. You cannot take the square root of a negative number. So both of those come into play. And we got 2 cases where we're taking the logs. We have to take both of those into account. So this means x minus 4 has to be greater than 0, and x plus 1 has to be greater than 0. Both of those have to be satisfied, because if it makes one of them undefined, then the whole thing is undefined. Well, x minus 4 has to be greater than 0 means x has to be greater than 4, and x plus 1 has to be greater than 0 means x has to be greater than negative 1. You cannot leave that. What is our final interval notation? Okay. So basically, you got to satisfy both cases, x has to be greater than 4, and x has to be greater than -1. And what are we looking for? Since it's an and problem, we're looking for where they overlap. So that final answer is going to be from 4 to infinity. So our domain will be from parentheses 4 to positive infinity. Here's for that. All right, that last one there. All right, think through this one. Go ahead and copy that down. Okay, whatever we're taking the log of has to be greater than 0. X plus 3 over x minus 1 has to be greater than 0. All right, how do we do that? This is one we just did from the previous chapter. Wasn't on the test, it was right after this. Okay, a rational inequality. This is a case where we got to figure out where the numerator is equal to 0 and the denominator equals to 0 and do our checkpoints. Okay, so we got to find those out. We get a vertical asymptote at 1, we get a 0 at -3. So the numerator equals 0. That's going to be at x plus 3 equals 0, x equals -3. Denominator equals 0. That's going to be x minus 1 equals 0, x equals +1. So we do our number line. I got -3. I got 1. And then I got to do test points. So I got to pick, let's do -5. -3 to 1 goes through 0, so I can use 0. And I'm going to use 3. And you're going to test to see where it's going to be positive, where it's going to be negative at. So if I plug in -5, -5 plus 3 is a negative. -5 minus 1 is a negative. Negative divided by negative, positive. So everything in that interval is going to be positive. 0 plus 3 is a positive. 0 minus 1 is a negative. Positive divided by negative is a negative. So everything here is a negative. In the last case, when I plug in 3, 3 plus 3 is a positive. 3 minus 1 is a positive. So I got all that. So right there, I get those two intervals. So my domain is going to be from -infinity to +5 union 1. No, that's a +5 to that breakpoint, -3. Sorry. And then from 1 to infinity. All right, that's back for those rational functions we did this not too long ago for those. All right, kind of the introduction to logs. Okay. Page 457. This doesn't look good.